So can you believe you finally made it to what we'll be considering our last topic in the class, simple linear regression. It's probably my favorite topic because I think it's very relevant. It's actually something we used to teach in the second statistics course, but with the major changes we've made, we wanted to bring a little bit into this class just so it gets you a little bit familiar with regression before you move on to analytics. And you may not cover regression at the level that we did, but it's so important to just understand relationships with data. And that's really what regression is. It's looking at two variables and determining if there's a relationship between those two. So we're going to look at just a little bit with simple linear. I'll talk about coefficient determination and the correlation coefficient just a little bit. But again, it's that what is regression is what we're really trying to get out of this. And when we look at regression, we're looking at the relationship between two variables. These two variables can be anything. One usually is considered the independent, and the other one is considered the dependent variable. So if you think about that, one is that one you can control. One is one that if you move up and down, could be just writing more money to your advertising agency. You hope the other dependent variable goes up or down. So a good example is your education. You have control of the number of years of education that you get. And so let's say you get your bachelor's and then you go on to a master's. You're doing that because you hope your dependent variable of future salary goes up based on the number of years of education. So let's think about that, and we'll look at that in terms of a scatter plot. And let's say I looked at everybody in our class after they've graduated, and some of you may have gone to school for 4 years, some 5. And when I say 5, we're talking about graduate work. We'll assume that 4 years means actually completing a degree. And if you were to look at that as your X and this as your Y, this would be the number of years of education, and this would be the dollars that you plan to make one day. And so what we hope is that the number of years of education means the more money. So if we were to kind of, put all those on a scatter diagram, similar to something you did back in the first couple of chapters of this class, does that show some type of relationship? So what we do is we like to draw a line through that data, the best fit line. That's what least squares method refers to, is what is the best line that we can draw. We then come up with the slope of the line. Anybody remember y equals mx plus b? We do the same thing, except now it's y equals beta sub 0 plus beta 1x. Beta sub 0 is the same as b. Beta 1 is m. And we just move those around a little bit, but they're identical. So what does that mean? Well, it looks like there's a relationship. It looks like it's going up. And I should be able to say, well, if it goes up by, let's say, that's for every year of secondary education, my salary goes from, let's see, we'll say this is $20,000 here. And at that point is $25,000. What does that mean? That means that for every year of education, I hope to make $5,000 more. And of course, we know that when it crosses the y-intercept, that's what it means if you have 0 education. You'd be making $20,000 according to that example. So that's what regression really refers to. In terms of doing it, we're just looking at simple linear regression, but we can also, something that we're not going to cover, even though I wish we were, is multiple regression. And multiple regression looks at more than one independent variable and compares it to your dependent variable. So years of education, your years of experience, those two variables have a lot to do with what you're going to make in your job. So those would be two independent variables comparing to one dependent variable. That's multiple regression. There's your linear regression model. That's your equation that you use, where that E represents the amount of error within the model. Because obviously there's error. We're not perfect here. But we kind of forget about that once we create it. It's just B sub 0 or beta plus beta 1 times our independent variable, which is x, will equal our dependent variable. You can see all those there. Again, this is an example where I'd rather Excel do the work for you. I hope I've made that very clear. I'm not interested in you becoming math geniuses here, or doing things by hand. It's more about using statistics in the right way to make good decisions. If our slope is going up, like the example that I showed you, we have a positive relationship between x and y. If we have an example where it's going down, then what we have is a negative relationship between the two. And if there's no relationship whatsoever, then we'd expect that line kind of to go all the way across. I'll give you an example here. How about IQ as the y variable and x being your height? Do you think how tall you are determines how smart you are? Well, if I was to put and chart everybody, I would expect it to be all over the place. And therefore, there is no relationship between your height and your IQ, and the slope would be 0 in that case. So if we, again, graphically do it, let's get to our example here. Again, showing all the different components of it. Here we go. And we look at, we're just going to do a small one with 5 previous sales, looking at this to see if advertising has a relationship to their sales. So here's our data. Here's the number of ads, and here's the number of cars sold. And is there a relationship? Now, you'll see at the bottom here, it's getting into the calculation. I'm not really concerned with that. I'm more interested in you putting it into Excel. So go ahead and you can do this yourself. Just type these directly in. And using the Excel tool to do it, just go to Data Analysis, you'll see Regression. Then from there, you're going to put your Y range in as your dependent variable, that's C1 through C6. Now, C1 through C6, let's take a look at this again. I'm going to go back. That's this data here. That's C1. Let's include the label. C1 through C6. B1 through B6 is then our independent variable because we can control how many ads we put out there. We cannot control the number of cars. We are assuming the number of cars sold is dependent on the number of TV ads. So going through that, what we get is this beautiful looking regression equation. And I know it's hard to read on the screen here. I'm going to break it up into small little parts. But this is what we really care about in terms of regression. Now, the first thing is we get this thing that gives us our equation. So at the bottom, this is actually down here. This is what I'm showing you right now. And your equation then is going to be those two coefficients. The 5 is your slope, and the 10 is your y-intercept. So let me draw that up on the board to get an idea of what this shows us. X being the number of ads and the number of sales being on this side here. And so if we look, there's what, 1, 2, and 3. So we do 1, 2, and 3. And then we'll have 10 here, 10, 15, 20, 25, 1, 2, and 3. So if I plug that out, that value of 10 is our y-intercept. That means that's where our line hits here. Then for every ad that we do, the slope is telling us that it goes up by 5. And so we create a line that looks like that. That's our slope. So that would then be y equals 10 plus 5x. And that's our regression equation in that case. So what does this mean? If we have 0 ads for the week, we'll sell 10 cars. If we have 2 ads, then we will sell 20 cars, and so on. For every ad, we seem to get at least or approximately 5 cars sold. So that's the first component. And looking at this, it then shows if you were to use confidence intervals for each of these, which means, of course, the value isn't exactly 5. It's plus or minus something, and it can obviously range. We're not going to even talk about that here. Is the model significant? Is there a significant relationship here? There's this value right on this side. If that's less than, guess what? Which value do you think? If it's less than 0.05, right, because the p-value, that's what significance f is your p-value. If it's less than 0.05, is there a significant relationship here? And the answer is yes. In this case, there's a significant relationship between the ads and your sales. And that tells us, hey, that means ads do help us get sales within our company. Also, what we have on here is something called multiple R and R squared. So multiple R represents the strength of the relationship. So if it is a value close to 1, it is considered a very, very strong relationship. My rule of thumb over the years, this probably isn't in the book and it's okay, but 0.6 has been my number for your multiple R. If it's greater than that, then I feel like I can use this regression equation as a predictor. I consider it a very strong relationship. The other one that's very interesting to see from here is your R square, and that's what's called the coefficient of determination. And what that tells you is the percentage that can be explained by the independent variable. So in this case, the fluctuation of sales, 87% of that fluctuation can be explained by the number of ads. So if you ever wonder why there's so many car ads on TV, it's because there's a significant relationship. In this case, it's saying 87% of their sales, the fluctuation of their sales, can be explained by the ads. That's why you see so many ads on TV, if this data, of course, is accurate. If you want to look at a scatter diagram, you've done this before. You did it, I think, back in Chapter 2. Here's how you do it again in Excel. And going through those steps, you can select the different values. I hope you already know how to do this. And there's a lot of different components to it. In the end, you can get something that looks like this. And that's where the y 5x plus 10 comes from. And you see what that trend line looks like. And if I were to take that all the way to here, you would see that the y-intercept would be 10. So that's just a brief introduction to regression. There's so much to it, but the most important thing for what we want you to understand before you get into analytics is that data has a relationship. It's why we're looking at data. We're either looking at data like we did in the previous chapters and looking at significant differences, or just trying to describe it. And in this last chapter, we're looking at significant relationships. And if we have a significant relationship, we can do more with it. I can put more ads on TV. I can get more education to make more money. All things that are in my control that can then have a impact, hopefully, on things that really mean a lot to me, like making money. I want to also, just as a final note here, stress this is not causation, this is correlation. I'm telling you there's a relationship. I can't really technically say that one causes the other. All I can say is that when one goes up, the other one goes up, and vice versa. So we're looking at relationships. That relationship is correlation, not causation. And it's wonderful to play around with when you're trying to make real business decisions. So with that, why did we go through all of this? Why are we learning stuff about statistics? It's because data is out there. Data is going to be an integral part of every business. You have to be able to describe it like you did in the first couple of chapters. You then have to be able to make decisions, which is why you learn probabilities. And then you have to make determinations of, is your data significantly different than what you expected? Is it good enough? What is actually happening out there? And that's what we did in the last few chapters. And then finally, do we have relationships with our data? And that's what we finished up with here, is looking at relationships. And that's statistics for what we want you to understand in a business course. And hopefully this gives you a good snippet of what you really need to know when it comes to statistics.